Right, good day. Good day. We have our, you can see I have several items here. It is because today I'm introducing to you a different area of our algebra. When we last talked, we talked about A, we talked about B, we talked about X as terms that represent an unknown value. So in this case, we are still continuing with those unknown values. It means if we have an unknown value, we take another unknown value. How do we combine those things? This is what we are looking at today. We are considering like terms, as for example, we have these red pegs. So these red pegs here are 5. If we are in the shop and then someone says, in fact, your little sister says they want to buy 2, and yourself, you want to buy 3. So this can be combined. And now we are going to the till, buying just as one item. It will appear 5 pegs as one item on our till slip. But if we are buying these 5 red pegs, and they have a different price from the 4 green pegs. So when we go to the till, because they are priced differently, so we have 2 items, the 4 green pegs and the 5 red pegs. They cannot be combined to be one thing. So they are unlike items. So in this case, we will consider them as unlike terms in mathematics. So in this case, I can have several as well. I have the khaki, the purple, we cannot combine. But if we pick 2 purple and we pick 1 purple, we now say all together they can be combined. We are going to pay for 3 purple pegs. So it's one item. Fine. Let us consider in terms of our algebra. So our algebra here, we said A. We took another A. So how many do we have? We have 2A. Fine. We have an A and an A. We have 2A. So if I pick another A, I'm adding to the first 2A. So altogether, how many do I have? I have 3A. They can be combined. From the pegs, you can understand it. So the point is, 1A is the same as A. So they form 3A. If I pick another 2A, so I have another 2A. So 3A plus 2A will give me 5A if they are combined. So enough for that one. But if I have a C can only combine with another C to form 2C, and we can combine with another 2C. If I have 2C here and another 2C here, the total becomes 4C. But if I have my C and then I pick an A, can we combine these? This is remaining as 4C and an A. So they are 4C plus A. We cannot combine these two. Even if we are picking the B, I have the B here. If we pick 2, and then we will say, I will be giving you these ones to check if you understand what I'm talking about. If I give you 2B, you pick another C, you then pick an A. Can we combine these? No, because the C is different, it's a different item, different item, different item. So they remain as A plus B plus C. Thank you. All right. So there we go. We can make a combination of letters. If we can say AB, we can say AC. We can say this is AC, this is CA. They are the same thing. It is the arrangement that matters. So AC can be written the same as CA. So don't worry. If it is AC plus CA, then it still gives us 2AC. Remember, in algebra, we are starting with the letter that comes first on the alphabet. So we can't write this one as CA, but we can only write it as AC. Fine. It means AB, the same. If we take AB, we pick another AB, we have 2AB. But if we take 2AB plus an AC, it remains as 2AB plus AC. They are different items. They cannot be combined. This one, they are the same. 1AB, 1AB, 2AB. 1AC, it means 2AB plus AC. They are different. Remember, terms can also be written as a squared is an independent term, another a squared, so we can combine to say we have a squared plus a squared, which is giving us 2a squared. I hope you are understanding me, because next I will be moving to some persons where I will say now, if I have an a and I have an a squared and I have an ab, what is the answer? Okay, thank you. The answer is a plus ab plus a squared. Okay, because we can't combine these. All right. If I am going to another point, okay, let me continue to ask you. If now we have an AB, fine, and we have a 3. So if we say AB plus 3, 3 is a constant. I think you remember from the previous lesson. 3 is a constant. So if we say AB plus 3, the answer remains as AB plus 3. 3 is just a number, but this one is an AB. So AB and the 3 cannot combine. So constants are also considered as items on their own. They are like terms. If we have a 3, we have a 2, we have a 5, then we can combine 3 plus 2 plus 5. And then the answer becomes 10. So they are like terms. Okay, they cannot be combined with AB. Let us have this one as our first question. Okay, yes, you have already your hand up. This one remains as 2A plus B because we cannot combine. If we have another one, this one, okay, yes, yeah, we can combine this one to form 5A. Fine, thank you very much. And this one, yes, it can be combined to form 5m squared. Thank you. This one we have a 15ab plus ab. Yes, right, we can form 16ab. And then we have this one. Now we are subtracting. And you remember directed numbers. Okay, so our answer becomes negative 7y squared. Thank you. Now we have got, we have talked about how to simplify. We need this one. Write down the number of terms in this one. How many terms do we have? We have been talking about the red as a different item, So we said each item is a term. So how many items do we have here? Yes, we have 4 different items. The 4 is an item, the 3B is an item, the 8C is an item, 7A is an item. So altogether we have 4 different terms. And all of these terms are unlike terms. So we cannot combine any. We cannot collect like terms. Okay. Thank you for that one. Now let us look at this one. We want an answer. Yes. Yeah, the constant is plus 15. That's correct. It is a term on its own. If we are moving on to say, let's be able to, I think from now on, after looking at this, I will give you the other worksheets and you will work on them in your groups, in your separate groups. So let us look at the last one. I will give you the last one, simplify. So the 3A and the 2A will give us 1A. We write it as A. The 4B and the other minus 4B will give us 0. So our final answer becomes A. Thank you very much. Let us have the next one, but this one, let me be giving it to your groups. Yeah.